So we are now in a binomial theorem. So par n is equal to 1. So a plus b1. So 1 0 factorial a1 b0 plus 1 1 a n minus 1 b1. So here is this equal to 1. How you can open this one? 1 0. So this is the formula. I have write down here, but let's do it. So 1 factorial divided by 1 minus 0 factorial and 1 factorial. So how it's come? So 1 is 1, 1 minus 0 is also 1, and 1 factorial, so 1, so is equal to 1. So this is 1, b0 is also 1, so this is a. 1 by 1 is also 1 by definition. So a1 minus 1 is 0, a0 is equal to 1, so b1, so this is equal to, when n is equal to 1, so we got a plus b. And this time par n is equal to 1. And when we put n is equal to k, this is very important. So the same series a plus b power k, so k0 factorial ak, the power of a start from k and b0, and the second term k1, the power of a decreasing a k minus 1, the power of b increasing b1, the second term, the third term k2, so b k minus a k minus 2, the power of a is decreasing while the power of b is increasing. And for k3 we got this one, this is kr, general term a k minus r b r, and this is the last term k by k. So if you find out sometime k, so k minus 0 factorial and k factorial, so you can further do it. So this is par n, so it's true par k, it's true par n is equal to 1. And when you put n is equal to k plus 1, so this is the formula 0 k plus 1, same thing you put here, k plus 1. So we got k plus 1 is 0 to k plus b. There is some special thing in the series. What is it? Note that the value of a, the first term, is decreasing in the series, while b is increasing, which I told you in the last slide. This is important. And there is one more term in the series, so that the term is if there are n term 100, so in the series binomial theorem, if a plus b is equal to 100, so the total term will be n plus 1. There is one more term, so you gonna got 101 term. If you got 100 power n, so you will got 101. So there is one more term in binomial series, very important in the exam. And let's say a plus b is equal to 20, so the term, there is one more term, so we have 20 plus 1, 21 term, very important in the exam. And now this one, so it is very important. If the number of n is odd, so the number of term will be even. Let's say if a plus b is equal to 7, so the number of term will be 8. Term mean 1 2 3 terms, this will be 8. So there will be 2 middle terms. And if n is even number, this is 8, so we got 9. So the number of term will be odd. If it's even, let's say a plus b is 8, so the number of term will be odd, 9. This is an example, so only one middle term. If n is even, then the number of term will be odd and have only one middle term. If n is equal to odd, the number of term will be even and there will be 2 middle terms. How you will find it? Such that when n is equal to even, a plus b is equal to n, so the middle term here in the second one, if it's even, so there the middle term will be only one middle term. In the series, binomial series, you can find by n plus 2 divided by 2. That term you can find. It's come in exam. It's very important. If n is equal to odd, then there are 2 terms. N is equal to odd, the number of term will be even and there will be 2 middle term. So if n is equal to odd, so then a plus b, n have 2 terms. And the 2 term, how you can find it? n plus 1 by 2 and n plus 3 by 2 terms. It's very important, this one. And if we change the sign a minus b, so far we did for a plus b n, and now when we change the from positive to minus, so the expansion will remain the same. Then expression has alternate positive and negative sign. So if the first term is a positive, the second term of a will be negative. This will be positive, and this will be like alternate means one after other is different. So the first term is positive, minus second term is minus, third term is positive, fourth and minus 1 at the end. So the general term, it's come in exam. This is important. There will be a question in the exam that find the general term. So this is the equation t r plus 1 n by r factorial a n minus r b r. So n r become n factorial r factorial n minus r factorial a n minus r factorial b r. So this is the general term in binomial series. So here is an example. Find the 10th term in x plus 2y 16. This is n is equal to 16, and find the 10th term. This is an exam question. Solution: we have a general term like tr plus 1 is equal to 10th term in the expansion of x plus 2y 16. So we have this equation tr plus 1 n r a n minus r b r. We can write down this one. And factorial mean if we have 5 factorial, it's mean 1 2 3 4 and 5 are 1 2 3 4 5 up to 5 we can go. This is called factorial. It's a cramp law. I will give you another lecture on that. So here we have 16 is our n, which is the general term nr. So 16 by 16 factorial r. A becomes 16 minus r. Br. So this is br. So n is equal to 16. N is equal to 16. The power a is equal to x. B is equal to 2y according to binomial series. A plus b n. This is the binomial. So our term is 10th. So we choose r is equal to 9 because tr plus 1. So when we choose r is equal to 9, so it means 9 plus 1. So this is exam question. It's very important. So we choose 9. We are going to find 10th term, but we have to choose the r in general term. R is equal to 9. So here is 16 into r, 9 plus 1. tr 9 plus 1 become t10. 16r, a 16 minus 9, b 9. So t10, 16 factorial. This is like this. 16 9. Here is nr. So first is 16 factorial here. N minus r is 16 minus n minus r 16 minus r. We choose 9 for r factorial, and this is 16 factorial. So when you go and calculate 16 factorial, 16 minus 9 is 7 factorial, 16 factorial, and in the equation x7, 16 minus 9, we got 7. So x power is 7, and b9. So in place of b we can put 2y. Here I put 2y. So 2 7, 2 9 and y 9. So 16 16 we cross it. 7 factorial we remain, and x is equal to 7, y is equal to 9, and 2 power 9. So when you calculate here, 2 power 9 is equal to 5 12, and 7 factorial is 1 2 3 4 5 6 7. So it's become 5 0 4 0. So x7 9. So our 10th term in this example is 0.1015 x7 y 9. Very important, keep in mind this. And there is another thing, it's very important. It's a binomial theorem, but Pascal triangle. So we can conclude many things from this binomial. It's very, very important, and it's a very beautiful expansion in the mathematics. So we can find binomial coefficient such as a plus b n is whole number, a plus b is binomial. So here is the very beautiful thing. So a plus b0 is equal to 1, a plus b1 is equal to a plus b, a plus b whole square is equal to a square plus 2ab plus b square, a plus b cube. When you split it, so a cube 3a square like this, a plus b 4. When you split it, a4 you got this one, and a plus b5 you got this one. So here is the beautiful thing. So this is a plus b0, the coefficient is 1. For 0 it's 1. For 1 we have two coefficient, a1 and b1. We know that if there is a in maths, we can say that the coefficient is 1. So a plus b is 1 1, a square plus 2ab plus b square is 1. We pick coefficient 2 here and then 1. Similarly in 3, so we got 1, we got 3 here, we got 3 coefficient here, we got 1 here. Similarly in this, we got 1, we 4 6 4 1. When you see the coefficient it's called Pascal triangle. It's very important to calculate, and you can easily split the binomial series. So this is an example. Keep in mind it's very lengthy, but let's find out x plus y power 4, x plus y n by Pascal formula. So like from here x plus 4, when you